Okay, guys, the purpose of this video is to help you understand why network equals changing kinetic energy, or why the Ewok. To fully understand this, we got to talk about vector dot products. Now, this is something that you haven't learned before, so that's why this is optional, right? I want you to have a chance to understand by learning something a little bit new. So when I take the dot product of two vectors, what I'm really doing is multiplying vectors together. We've seen with the work equation that the force times the displacement vectors gives us the magnitude of the force times the magnitude of the displacement times the cosine of the angle in between. And what we're really doing here is we're finding the projection of the force. So if this is the force and this is the displacement vector, F cosine of theta, or net force cosine of theta, is really the projection of the force vector parallel to the displacement. So that's really what we're doing with dot products. Now, one thing that we can do with dot products is we can break the force vectors into their components, just like we've done with force vectors with velocity vectors. So we can write F as Fx plus Fy. We can write the displacement vector as dx plus dy. Now, with the dot product, it distributes. So one of its properties is that it distributes just like an algebraic expression. So f of x plus f of y dot d of x plus d of y becomes f of x dot d of x plus the other remaining terms that you see written there. Now, what does that boil down to? So let's start here. So for each of these, you get the magnitude times the cosine of the angle in between. Now, for my f of x times d of x and my f of y times d of y, the cosine of the angle in between those is either going to be 0 or 180. If they're both positive or both negative, it's going to be 0. If they're in opposite directions, it'll be 180, it'll be negative. So we can really treat these as just the force value times the displacement value in the x direction, whether it be positive or negative, and this part becomes kind of moot. I'll show you in a minute. Now, the perpendicular vectors, f of x dy, f of y dx, are always at 90-degree angle to one another. So no matter what, they are always going to be multiplied by cosine of 90, which means those terms cancel out. It's only my parallel vectors that are going to have a value. So what does that mean? So what that means is I can write F dot D for the two forces as the x component times the x component of the force and the displacement plus the y component times the y component. Now, the way it works is, let's say both f of x and dx are positive. Well, then I'm going to get positive f times dx. If they're both negative, I'm going to get negative f times dx. So that works for work, right? If the displacement and the force are in the same direction, it's positive work. If they're in the opposite direction, it's negative work. So if this is negative and this is positive, I get negative work. If this is positive, if this is negative, I get negative work. So I can just put in the values for f and x, f of x and delta x, and it'll come out to either positive or negative depending upon how those are aligned. And so that's how we can express f dot d as a sum of the components f of x times d delta x plus f of y times delta y. And that's an important first step in understanding why Ewok works.